So as Patrick mentioned, I'm from iPullRank. We're literally the best SEO agency in the multiverse. I was also just named Search Marketer of the Year for a second time. No one else has ever had that, so that's me. I'm the GOAT. And lots of slides. Feel free to grab this. I'll pause. You can take my picture as well. All right, so here's the thing. Over the last 2 years, we have gotten so many intimate details about how Google works, but nothing has significantly changed about our major SEO software, which makes no sense to me, right? Like, we got the leaked documents, we got the leaked data from Mark Williams Cook, we got all this information, and our tools are still talking to us about text-to-code ratio. Like, what are we doing here? And in the spirit of how I'm presenting myself thus far, I just want to start with an I told you so. So, back in 2023, I wrote this article for Search Engine Land about how SGE at the time, which is AI Overviews now, works, and why retrieval augmented generation is our future for this industry. And in this blog post, I shared with you where I replicated AI Overviews, again, before it was launched, because I wanted to figure out how it works. Relevance engineering, guys. And so what I did is I built a RAG pipeline using Avs API, which is a SERP API, Llama Index, which is effectively an orchestration tool for RAG, and then the ChatGPT API. And so when I did it, it looked very close to how SGE at the time actually looked. And there's Patrick, shout out to him. And I learned a lot at that point. That's why I came across the idea of chunking and, you know, all these different things. And then I built a model to project what would be the impact to people's traffic. I projected at the time there would be between 20 and 60% in a click-through rate loss, which we are all seeing now. I don't have to prove it to you at this point. And in fact, I did it for a very specific website. I did it for NerdWallet. I said they were going to lose 30.81% of their traffic. And people were like, you're crazy. Well, a couple months ago, they hit 37.3% in traffic loss. So,
used as an interjection in trap music, this vowelless word conveys the sound of tires screeching. Michael.
What is skirt?
Yes, well said.
So that's y'all. I did draw two wrong conclusions, though. I thought that you could rank, you know, anywhere in the SERP and then appear in AI overviews. And I also projected, I was like, hey, we're going to have these big context windows, and it's going to be really important that your pages are really comprehensive so you stay in there in the subsequent turns in the conversations. What I didn't know about at that point was query fanout. So I was close, but not close enough. So query fanout is this idea that these systems, all the RAG-based systems, take the prompt and then they extrapolate on it into a variety of different queries or synthetic queries that are then run in the background to retrieve different chunks and then feed those to the language model for synthesis. And I've been talking about this since Google I/O when I first heard of it. And I was like, hey guys, I think this is the place that we really need to focus. And why do I care about this? Because AI search is very much like a raffle. We don't have control of the synthesis pipeline. All we have control of is the inputs that we put in there. And for us to have as many raffle tickets as possible, you want to rank for as many of these subqueries as possible. Because like I said, the whole reasoning chains that happen in the background, we have no control over them. But what they do is they take all these passages and they compare them to each other, and then they're saying, okay, which ones should we actually be using for this synthesis pipeline? So let's talk about a few trends real quick about what we're seeing from this actual data. So this is one of my favorite studies to share. This is something that ZipTie put out back in May, where they look to see what is the overlap between ranking in Google and ranking in Perplexity and ChatGPT and so on. And basically what the data says is you have a 1 in 4 chance of appearing in these channels if you rank in the top 10 in Google. I can't run a business on a 1 in 4 chance. Y'all can do it if you want to be SEOs forever. But what about ChatGPT? So I reached out to my friends at Profound, and I was like, hey, do you guys have any data on query fanout? And so this is something that they had already shared, which was kind of an analog to the data I just showed you. There is a 19% overlap between ranking in Google and appearing in ChatGPT. So how is that just SEO then? We'll keep going. 62% of the citations in ChatGPT come from outside of Google search, meaning that it can come from training data or some direct pipelines into ChatGPT. Some other really interesting data that they share with me is that there is no position bias in ChatGPT. So the positions that you rank in contribute the same. You don't have to be number one, you don't have to be number two. If you are being retrieved, they're considering everything equally effectively. And then what we're seeing is that if you have multiple queries that a given URL ranks for, you have a higher likelihood of being used in the response. So effectively get those pages to rank for as many things as you can. And then also, if your domain ranks for a lot of the queries, again, you have a higher likelihood of appearing in the final response. But after that second query, there tends to be diminishing returns. Like you don't get the same delta in performance. So really focus more on the first 2 or 3 queries and then, kind of just keep going on with your life from there. So what about Gemini? So we actually are getting a lot more data on what's happening in Gemini right now. And this is some data that came from the Sierra Interactive team. They published a couple days ago. There's an average of 10.7 queries per prompt for the the query fan out. And it can be up to 28 queries that are being run from what they're seeing in their data. And these queries, of course, are very long tail in that they're seeing that they're an average of 6.7 words, but they can be as long as 13 in the data set that they're looking at. Here's the one that I've been kind of harping on for a while, and now we have more data to reflect it. 95% of the queries in the query fan out have no monthly search volume. When we first started talking about query fan out, a lot of people were like, well, why would you want to generate queries? Just use people also ask. There's a lot of queries that are not going to come up in people also ask because these systems are generating them. And so we're seeing studies come out from the bigger data providers saying that like, oh, well, a lot of these things that are showing up in these responses don't rank for anything. That's not true. These platforms are not showing you queries with no monthly search volume. So they're presenting a conclusion that doesn't necessarily align with reality. So how does this stuff actually work, right? So query fan out is a function of, or part of retrieval augmented generation, which is basically you get a query, you embed it, and then you pull a bunch of candidate documents, and then you serve those to the language model for grounding, and then the synthesis happens to generate that response. And so with AI mode and AI overviews, the query fan out differs because for AI overview, they need to return that as fast as possible. It could be something like 5 to 10 queries, whereas for AI mode, you can see like the 20 to 28 that we're talking about. And so Bing has something very similar. Krishna talked about it yesterday, but specifically, they wrote a blog post about Bing's Prometheus with this orchestrator thing that grabs all these, what they call internal queries, to then generate these responses. So all these systems effectively work the same. They have just different nuances in how they do it. So as far as the answer generation process, they get the query or prompt from the user, they expand it, they route it to different types of content based on what they expect, and then they retrieve that content, select the items that they think make the most sense, hand it off for synthesis, and then generate that final response. So it all starts with the query. And the queries can come from either the lexical side or the semantic side. It doesn't have to be one or the other. All of these systems are effectively hybrid and have been for a while, which is why so much SEO software is obsolete. So, to that end, there's a variety of different things that they do to expand these queries. And we're going to go through each of them. So one is called intent classification. So based on what they think the user needs, they're going to go through these different stages to figure out, like, is this a query that makes sense? So they look at the information domain. They then look at the subdomain of the information, not the domain like host, like the taxonomy of information, basically. They figure out what the task is that the user's trying to do, and then they run it through risk and safety profiles to make sure it's not going to give bad responses. Then they do what's called slot identification. So it's effectively a series of variables for what they think the user is looking for. So there's implicit and explicit slots that they're basically filling in where they're breaking this query into smaller components. And then what they do is they do what's called latent intent projection, where they basically plot these queries in multidimensional space and see what are the other ones that are close to them, and they feed that into the pipeline as well. And then they're just going to do some of the things that you've always known about query expansion, which is just like rewriting them and diversifying them so that they can get more of the information. From there, they are then going to speculate, like what are some of the questions that we think the user's asking, but we're not sure, and we're just going to use that to get more information. And then they're routing it to certain types of content. So some things are like, cool, that comes from the index. Some things we might want to hit an API. Some things we might want to go to images or videos or whatever. And this is one of the key things that you need to understand. It can't just be random content on your site. They have expectations for formats. And so they then are mapping everything to where they expect. And they also have like a cost and budgeting that they need to think about. So if it's an API, that could be very expensive at scale. Or they may say like, hey, let's run some BM25 queries, which is the lexical stuff, because that's generally cheaper than doing the semantic stuff. They make all these decisions on the fly effectively. So again, where you win or lose is, do you have content that maps to that format of their expectation? If you don't, well, you're likely not going to win on that query unless there's nothing else out there that fits that format. Okay, so where do we get this data from? You know, like, is it magically available? Let's see. So in this example, my query here or prompt is, who is Fonte from Little Brother, the gentleman that was DJing last night? If you go to the network tab and you click on conversations, in here is where you see the queries for ChatGPT. And it looks like this. So in this metadata section where it says search model queries, the queries are here. In this case, it was, who is Fonte from Little Brother hip hop group, Fonte Little Brother biography, Fonte Little Brother artist, Fonte Antonio Coleman, and Little Brother group info. Those are the queries that are used. These are the endpoints that you need to look for. If you're logged in, it looks like that. If you're logged out, it has the anon element to it. And you can just use like Playwright or whatever you use for scraping through your browser to grab that. And that same endpoint will also show you the search results that were used. So it gives you the title, the URL, the domain, and the snippet for that content. So for Gemini, you can use their API. They have a grounding API where you're basically using the Google search function to say, okay, I'm running this query, what is it going to return to me? You want to make sure that you are limiting the length of the response, otherwise it's going to be really expensive for you. And basically you're just looking to see, is there a response with queries? So in this tool that we have, the Gemini grounding detector, it basically says yes or no, and then you can see what the queries were, and then you can also see what sources it used. So as far as like how you generate this in the same way that Google also does, the tool that I made is called Qforia, something I put out I think back in like May or so. And what it does is it extrapolates the queries in the same way into these 6 of the 7 groups that Google does. One of the groups that we didn't include is recent, because we can't get those. And there's a lot of people that are like, well, that's not real data, it's just the model making it up. Okay, fine. If you don't like that, if you don't like what's actually happening, you can do what I call like a reverse intersect. So what you do is you get all of the citations in the AI overview or whatever it is, and you then look up all the keywords that they rank for, and then look where the intersect is between all those URLs. Those are likely to be the queries that were used, and that's real data for you. So how did I build this thing? What I did is I read a couple patents on how this stuff works. One of which is systems and methods for prompts-based query generation for diverse retrieval. There's another one called query response using a custom corpus. And then I identified like what are all the different queries that are available. So it's related, implicit, comparative, recent, personalized, reformulation, and entity expanded. And then I just started building. It's really just 3 prompts in the trench code. And so what I do is I generate the prompts based on the channel. So if you're trying to do it for AI overviews, again, it's going to be less queries, probably like 5 to 10. For AI mode, it's like 20 or more. And so it makes a decision based on what you put in there. Then it is this long prompt that says, hey, generate queries like this, and here are all the buckets for the data that we want. And I also updated this recently when I learned more about the whole routing thing, where it also says this is the content that's expected for this query. So you have a whole routing section with the reasoning as to why it's routed that way. And so the routing is based on this. Here are all the content types that we're recommending. You can, of course, add to these if you want it. And then here's the prompt that does it. So it's really that simple. It's like, hey, do what Google is doing. Give us what the response is. And so there's been a good amount of forks, which is great. Like, that's why I made it open source. I saw an opportunity. I was like, hey, here's a place that we can level up. And so there's 48 GitHub forks right now. People like Otterly literally just slapped their branding on my tool and put it out. Cool, I guess. People like Tyler made it way more actionable and did way cooler stuff on top. So shout out to him. But where are these guys at? How do our major tools not have this fundamental thing for where we need to go in the space? I don't know. But in the meantime, I'm gonna just keep making it better for y'all. So until our space like catches up and moves as fast as the world is, I'm gonna just keep making stuff. So there's some Qforia upgrades that I made. I added the Gemini grounding to it. I'd added the reverse intersect function. I took it out of Streamlit because Streamlit always breaks for me. Added ChatGPT scraping and some new charts. And so probably hard to see, but like these are all the grounded queries. Those are the cited sources. And then these are all the fan out queries that are generated by Gemini. We also have a tool that we call Chunk Daily, obviously after Chuck Daily. And I still think it's weird that there is no index of embeddings across the web. Like, I feel like it would be, I mean, it's not trivial because it's like web scale. You're talking about, trillions of pages or whatever. But the point is, we need this at this point. We need the ability to see the web in the same way that Google and ChatGPT do. Like, that's the reason why we have a link index to begin with. We wanted to see the link graph. But now we're missing out on this huge component that is so important to the future of search. So in the meantime, we've built this element called Chunk Daily, which will chunk your content. And then you can look through the page and see how the different chunks score against your queries. So I just keep building this stuff and open sourcing it. And eventually, the people that are $100 million companies will catch up. So there's some tools out there that are giving you some great query fan out data. So Demandsphere, who is one of our sponsors, they were the first ones to have it, which is great. And this is for ChatGPT. They also have the search intents, and they have a visualization coming soon where they can, you can see it in these sorts of network graphs. Prompt Watch also has it. So in their response details, they put the query at the bottom. But frankly, Profound has the most robust version that I've seen. They have all the queries there, and they also show you metrics on the variations of queries over time. You can see the diffs in the queries between the different runs, and they also show you how many per execution by channel. So thus far, I've only seen it for Meta AI and ChatGPT, but it just really gives you a sense of how probabilistic all this stuff really is. And Market Brew, which I don't know if you guys have heard of Market Brew, but their whole thing has always been like reverse engineering how the algorithms work and giving you a sense of, if I make this change, here's the forecasted impact. Like the things that companies always ask us for that are really nearly impossible to do, they actually do that. And they have a very query fan out focused content tool called the Content Booster, where you can get the queries, and they're also doing the reverse intersect thing that we do as well. So one of the cool things about this is that you can generate your content for the gaps based on the query fan out, and it's like an automated thing. So I would recommend you guys check that out if you have not. All right, so how do we actually use this data? So the way that we think about it is we've got to audit the content to look at it from like an AI readability perspective, and then do the semantic and latent intent research, restructure your content, improve it, of course, and then test and iterate on those things based on simulations that you can do by using the same sort of software that all these channels are using at this point. And so the 5 tactical steps are like, you got to pull the rankings based and figure out what the landing pages are for all those synthetic queries. Let me get out your way, Karen. And then generate vector embeddings for that content. Figure out what are the most relevant passages in your content, and then compare that to the competitors that are actually showing up in the citations, and then improve the relevance of those passages. But ultimately, the bigger picture thing here is that you require Omnimedia content strategies, because it's not just about the page on your site. It's about your content ecosystem. It's about Reddit. It's about your videos, like Cindy was talking about yesterday. All of the content, all your own earned and shared media is up for grabs for this sort of stuff. And so, again, tactically, goes back to writing the entity-rich, embedding-ready content. You know, the things that use all the stuff that we should have been doing as SEOs, but we don't really have the tooling to support, and everyone that says we're already doing it is mostly lying to you. Shit is real. Structured data, which you'll see on this slide, because it's an old slide. I'm not here to argue with you how and when it's used. Just know that LLMs can and do use structured data as part of their RAG pipelines. I've been saying it. People want to argue about shit they don't know what they're talking about. Can I get a witness? Well. We in the South, man. Anyway, your SEO basics, you still got to do them. You know, your heading hierarchy is really important. Making sure you're not blocking these bots, things of that nature. And then writing for synthesis is largely about like the chunking strategy, which again, I'm not going to argue with you about. It works. And so there was some insights that came from, how do I say his name? Is it Metahan? He wrote a blog post the other day about things that he, got out of looking at the Discovery Engine API from Google. A couple of the key insights I really thought were valuable was that there's a chunk size limit of up to 500 tokens. So it is layout aware, but they're still using a fixed size because it's just faster from a processing perspective. And the other thing is that they can include the hierarchy of the headings that preceded that chunk. So it can be like your H1 through H3 is being added to the chunk when they're considering it. And that's one of the reasons why you're seeing that headings are so important for this space. So we have a tool to really help you with that called Relevance Doctor, free. You know, it just like shows you what is your scoring across the different chunks on your content. And ultimately, when we talk about like passage optimization, again, it goes back to the headings usage. It's having very clear and succinct information in your content, using data points that are very specific and extractable as well, and also using semantic triples. So the question that I asked yesterday of Martha was really just setting me up for this. It's the idea that structured data isn't just schema. You know, these systems are crawling the web and looking at the semantic triples. Like she said yesterday, a definition or a member of a schema is a semantic triple. Think of like, it's like the subject, and then the colon shows that there's a relationship, and then what the information is on the other side. That's the same thing as the subject predicate object in text. It's just that you're explicitly providing that to the language model. So rather than writing sentences that are like the pros of buying a lake house or mini, you want something like a lake house, which is the subject, provides, which is the predicate, weekend relaxation and rental income potential, which is the object for homeowners. So be very specific. Less vague sentences, use data points in them, avoid ambiguity, write for readability and so on. And again, you have the opportunity to use everything that these platforms are using. There are open source equivalents to everything that they're doing, and they're all being very public about how they build this stuff. So you can vibe code a simulation tool where you can put your content in, make a change, have it compared to the other elements that are being pulled in from your query fan out, and then see what happens before you actually deploy it. So what tools do I recommend for the future? I think a lot of our sponsors have great things. I think AirOps is a fantastic tool. We use it a lot as well. But I actually prefer as much open source stuff as possible, because there's been too many times where I've looked at the bill for ChatGPT and someone has run like 5 million tokens and I don't know why. And there's no reason why I should be having to pay for that. So I actually really like N8N. It's lit. And it helps you close all the or a lot of the gaps in your existing SEO software. So this is what I was saying. I like the open source options. There's also Olama, which is a tool for using open source language models, and it has a chat interface just like ChatGPT. You can do RAG directly in it if you want. If there's a model you don't have, it'll download it automatically. And if you have a decent GPU, which most computers do at this point, it runs pretty fast as well. And so I use it integrated with Screaming Frog for generating embeddings, for helping us do content audits, things like that, so we can really scale it. And then I also run N8N open source as well. It literally just takes 2 lines of code to do it. And they've got over 1,100 integrations with most of the tools that you use. So you can do pretty much anything with it. And you can build a whole microservice, like an API that you can plug into to help close the gap. So a lot of the things that I walk you through, you can create an API on your own machine and have it, hit that for your data. And then one of the things I really love about N8N is that they have flexible human in the loop, meaning that you can have it send you a message on Slack before it moves to the next stage. You can have it send you a text or an email, and then that way it's not going to go off the rails because you have a lot of control of it. And then there's thousands of templates that are out there that are workflows that are pre-built for you. And you literally just click a button and then it's in your system. And so here's an example. Here's one that's freely available that does AIO analysis. If you don't like it, you can use it as your base and then adjust it for what you want it to do. And they also have this workflow feature, which I think they've actually copied from AirOps, where you basically just talk to it and describe what you want, and then it creates it directly there. And then if you're thinking about agents, I recommend Crew AI, which allows you to build autonomous agents and then plug it into pretty much anything that you want to do. So to wrap it up, SEO irrevocably changed. I mean, we can keep calling it SEO and make less money, or you can call it something else and make a lot more. And like I said, I'm from iPullRank. We have the AI search manual, which is 20 chapters of non-bullshit about all this stuff. And you can get it here. And you can get Qforia there. And you should come to SEO Week. And that's all I got.